All right, welcome to The Explainer. Today, we're going to tackle some of the biggest buzzwords out there: artificial intelligence, machine learning, and deep learning. You hear them thrown around all the time, sometimes like they're the same thing, but trust me, they're not.
I mean, seriously, have you ever stopped to wonder how your phone just knows your face? Or how Netflix is so creepily good at picking your next movie? Well, it's not magic. It's all thanks to this fascinating hierarchy of intelligence that's already running behind the scenes of our lives.
To really wrap our heads around all this, the best way to think about it is like a family tree. They're all connected, right? With a clear line from this one big ancestor all the way down to its super specialized descendants. So, sitting at the very top, the great-grandparent of it all, is artificial intelligence, or AI. This is the huge, overarching field. It's the whole grand quest to build machines that can think, reason, and learn, kind of like we do. And this is where that family tree, or maybe a better way to put it is Russian nesting dolls, really comes into focus. You can see how deep learning sits inside machine learning, which itself is just one part of the giant world of AI. One fits inside the other. Okay, so let's zoom in on that first big branch of the tree. Let's talk about machine learning. This is really where the big, fuzzy idea of AI starts to get down to business. So, what's the magic trick here? Well, the whole point of machine learning is that you stop telling the computer exactly what to do, step by step. Instead, you feed it a mountain of data and let it figure out the patterns for itself. It literally learns from experience, which is just incredible when you think about it. A good way to think about machine learning is like a super sharp student. It learns really fast, especially if you give it organized data, like a spreadsheet or a table. And the cool thing is, it can run on a totally normal computer. But, and this is a big but, it needs a human teacher to kind of point it in the right direction, to tell it which parts of the data are actually important to pay attention to. And believe it or not, you're already using machine learning all day, every day. It's that silent partner working in the background, keeping your inbox from overflowing with junk mail or teeing up your next favorite show on Netflix. It's everywhere. All right, now we're going to go one level deeper down the rabbit hole. This is where we get to the most powerful and honestly, the most exciting part of this whole family: deep learning.
Yeah, this is where things start to feel like they're straight out of a sci-fi movie. Deep learning uses these incredibly complex structures called artificial neural networks, and they're literally inspired by the way our own brains are wired, with all these layers of interconnected neurons.
But here's the catch. Unlike machine learning, deep learning is an absolute data monster. It needs huge amounts of data to work well. The payoff, though, it's kind of like magic. It figures out what's important all on its own, layer by layer, without any hand-holding. The downside is it needs some serious hardware, and trying to understand why it made a certain decision, well, that can be almost impossible. And this is where deep learning really flexes its muscles. We're talking about the really hard stuff, the tasks that mimic human perception. Things like recognizing your friend's face in a photo, understanding what you're saying to Siri, or helping a self-driving car see the world around it. These are the kinds of problems that deep learning was born to solve.
Okay, so let's do a little showdown. Let's put machine learning and deep learning right next to each other, because that's when the differences really start to pop.
So let's boil it all down. If you're going to remember just one thing from this entire explainer, what's the single biggest, most important difference between these two? And this table just lays it all out so clearly. You can see the trade-offs, right? Machine learning is faster, it works with less data, and it's what we call a white box. We can actually understand its decisions. Deep learning, on the other hand, needs way more data and computing power. It's often a total black box. But man, when it comes to performance, it can be absolutely unbeatable. And this right here, this is it. This is the absolute key difference. With machine learning, a human expert has to do something called feature engineering. Basically, you have to tell the model what to look for, like the color or size of an object. But with deep learning, it does all that work by itself. It just takes in the raw data and automatically figures out what features matter, from the simplest little edge in a picture to really complex ideas. So, a needle or a sword? Now that we know what makes them different, the really big question is, when do you use which one? You gotta pick the right tool for the job. What's crazy is that deep learning isn't really new. The basic ideas have been floating around for decades. It's just that in the last 15 years or so, we hit this perfect storm. Suddenly, we had big data from the internet,
We had these super powerful GPUs thanks to the video game industry, and then we got easy-to-use software that let everybody in on the action. So this makes the choice pretty clear, right? If you've got a limited amount of clean, structured data and you absolutely need to know why the model made its choice, you're going to go with machine learning. But if you're drowning in a sea of messy data, like images, text, or sound, and all you care about is getting the most accurate result possible, that's a job for deep learning. And that leaves us with this perfect analogy. Machine learning is the needle. It's a precision tool, it's understandable, and it's perfect for specific, well-defined tasks. Deep learning, well, that's the sword. It's this hugely powerful, complex weapon you bring out to tackle the biggest, messiest challenges out there. So the real question isn't about which one's better, it's about knowing whether your problem needs a needle or a sword.